Hi, my name is Tim Lucas and I'm creating this video to provide a comprehensive overview on practical applications for UAVs in the industry. The focus point for this video is photogrammetry. Photogrammetry is the practice of determining the geometric properties of an object from photographic images. This process requires that two or more overlapping perspectives be captured of the same object in order to extrapolate accurate depth information, allowing us to generate an accurate digital elevation model. If particular disciplines are also used in conjunction, we are able to also add scale to this data, allowing for volumetric and distance calculations to be made. You can now see me loading images directly from the UAV into the software. We are going to take this acquired data and use it to generate an accurate 3D representation of the area that the UAV was flying over. All of this data was recorded using an autonomous VTOL UAV designed by myself. The first stage of generating an accurate 3D model from these images is to determine the location that each image was captured in 3D space. We can accomplish this with software estimation. At this point, logged GPS and state information on each photograph can also be added for georeferencing the resultant data. Without this, the data has no global positions, however an accurate looking 3D model can still be generated. Now that we have completed this process, we have this 3D sparse point cloud. Although this will not be used in the final data output, it is nice to see that we have captured enough data to successfully recreate the terrain. Point clouds use particles placed in 3D space to provide a rough representation of the model. You may also have noticed the blue squares over the top of the terrain. These are computed camera positions representing the state and position of the sensor in 3D space at the moment each image was captured. The placement of the computed camera positions should be similar to the original waypoint-based flight path that was used. I decided to leave the images taken while the UAV took off, which you can see down there. They're stepped down a little bit lower than the others. This is a great example of how accurate the estimation is. We are now at the next stage where we're going to generate the 3D model. This is all done automatically with very few variable input options required from the user. It's quite user-friendly. I've sped up the processing as this usually takes some time depending on how powerful your computer is. We have now successfully reconstructed the depth. This gives us a basic terrain model which you can see here. At this stage we could send the data to other specialty software for extrapolation of niche data sets. Here's one such example where you can see the key on the side relates to the variance in elevation throughout the model. This is an accurate representation of the elevation throughout the model and the original terrain. We are also able to use similar processes to estimate the volumetric and distance information of landforms and objects within the model. This is very useful for aerial surveying applications, providing alternate methods for applications like stockpile calculations. Another particular possibility worth mentioning is agricultural surveying, where multispectral data gathered on plant health is overlaid onto a model like this. To obtain this data, the UAV has a predetermined flight plan loaded into it and autonomously flies over the chosen area using waypoints, then once complete returns for a landing. There is little on-site planning required to attain this data, and the rest of the work is done with a computer, as you can see me doing here. In many cases, this can be a far more effective way of surveying, as it reduces the size of the team required and the time that they are on site. This less intrusive approach also reduces liability and in a lot of cases is less hindrance to the normal operation of the site, meaning less downtime for the client. This data is also appropriate for many other DTM or DEM GIS based data extrapolation exercises. I've only touched on a few. I'm going to stay in the software now and generate an accurate texture for the model. This makes the model look much more lifelike, providing a nice looking representation of the terrain. Although the data that we have here is suitable for many uses, if we were trying to create a virtual tour or something which required a really high quality representation of the area, we would have the option to extend the quality further. Naturally, this would increase the time that it takes to process the data, and in many cases isn't required. We also have the option to export ortho photos and photo maps, where all of the photos are stitched into a 2D map of the area, such as this. Finally, I'm going to touch on some simulation-based applications for this data. As we now have captured an accurate 3D model of this area and its details, we can use this in some very interesting simulations. Let's put a house in the scene. It would make sense for it to be on high ground, so we'll go with that. We'll add a couple of cars on lower ground. Now, what if these cars were to be involved in some sort of accident? If we had more than one witness to the scene, it might be handy to know what exact viewing angle these witnesses experienced the event from. Knowing the height of the witness, we can now add a viewing angle for that witness. In this scenario, we're going to have 3 witnesses, one on the road, one on the hill, and a survivor in one of the cars. You can now see the same event play out from these 3 unique perspectives, showing unique environment variables that may have contributed to the accident. Obviously, this is just a mock-up, but if this UAV had been deployed over an actual forensic scene, we could have mapped the actual scene for post-accident evidence reconstruction and simulation. It goes without saying that quickly and automatically recreating 3D scenes and objects has many varied applications in many different industries. Let's stop the cars for a moment. We're now going to add an increasing sea level to the scene. As we raise the water, we can immediately start to see which areas are affected first. This model can be imported into a number of different simulation software to provide all kinds of data analysis. It's an accurate representation of the scene after all. This video only touches on one particular UAV dataset type. Various different payloads can be loaded onto the same platform to provide other aerial services. The possibilities are really endless. Thank you for viewing this presentation. I hope you found it informative, and please view the information attached to this video to get in contact with us to discuss how this technology could be applied to your field.